This is your presenter Asloob Mudassar, and I am presenting slide number 98 of the course on laser physics. Question is, lasers are used as the pumping source for other lasers. Tabulate a few important pumping and pumped lasers. The answer is, some lasers are used as a pumping source. Such lasers can selectively pump a particular wavelength in the pumped lasers due to narrow bandwidth of the pumping lasers. This makes them sources of high efficiency. A few such lasers are tabulated below. So in this table, we have on the leftmost side, the column contains pumping lasers. For example, all these are the pumping lasers. In the center column, we have either the wavelength or the bandwidth or the status that the pumping laser is continuous or pulsed, and some particular wavelengths are also given. And on the rightmost, that is in the third column, we have the lasers which are being pumped by the lasers on the left hand side. So these lasers are pumped respectively by their corresponding lasers in the first column. So let's give a brief review of these lasers. So for example, the argon, the argon ion laser, it has a spectrum in the blue-green wavelength, and the wavelengths around 488 nanometer and 514 nanometer. So it has a continuous wave status. So this is the continuous wave laser. This is a gas laser. It has a continuous wave output, and it is used to pump dye lasers and also the tie sapphire lasers, which is called the titanium sapphire laser. So this is the titanium sapphire laser. It has an ion Ti, titanium ion, titanium plus 3 ion, and then we have this ion doped in Al2O3 lasers. So this is the titanium sapphire laser. So argon is basically used to pump dye lasers, or it can also be used to pump titanium sapphire laser. The second one is excimer laser, nitrogen laser, copper vapor laser. All these three are the pulsed lasers. The excimer is a pulsed laser in UV. It operates at two particular wavelengths. The wavelengths are 308 nanometer and 248 nanometer. Then we have the nitrogen, again a pulsed laser. It has an operating wavelength of 337.1 nanometer. Then we have the copper vapor laser. It operates at 510.6 nanometer. So I have given specific wavelengths specific to these three types of lasers. All these are pulsed lasers, and these are used to pump dye lasers. So many type of dye lasers are possible here. Then at the third stage, then the next stage is gallium arsenide, aluminium gallium arsenide quantum well lasers. So it operates at 800 nanometer, and it is used to pump ND-YAG, ND-YLF, ND-YVO4, and ND-glass. So this is the neodymium YAG laser. YAG stands for yttrium aluminium garnet. Then we have ND-YLF, which is the neodymium yttrium lithium fluoride. So this is the yttrium lithium fluoride. Then we have ND-YVO4, which is the neodymium doped yttrium orthovanadate. And then ND glass. So this is a neodymium glass laser. So these are the lasers, these are the pumped lasers, and the pumping lasers are the gallium arsenide, aluminum gallium arsenide quantum well lasers operating at 800 nanometers are used to pump these lasers, which are the pumped lasers, ND-YAG, ND-YLF, ND-YBO4, and ND-class. Then we have indium gallium arsenide or gallium arsenide strained quantum well lasers. It has a bandwidth of 950 to 980 nanometer. And it is used to pump the lasers, that is the pumped lasers are ytterbium YAG, erbium glass, erbium glass lasers. So these three main categories of lasers are being pumped in this range of a wavelength, that is 950 to 980 nanometer, and the pumping lasers are indium gallium arsenide strained quantum well lasers. The next we have GAIN P and aluminium GAIN P quantum well lasers. So these operate in the range of 640 to 680 nanometer, and the lasers which are used to pump them are the alexandrite, chromium LiSAF, and chromium LiCaf lasers. Chromium is the ion in both of these, that is LiCaf and LiCaf. LiSAF and LiCaf laser are the host crystals for the chromium ion. And this LiSAF stands for lithium, strontium, aluminium, and F stands for F6. And here in the LiCaf we have lithium, calcium, aluminium, and F stands for F6. So these three broad categories of lasers are pumped in the range from 640 to 680 nanometer. Okay, and the next and the last one is aluminium gallium arsenide quantum well lasers operating at 785 nanometer. It is used to pump this laser TMHO YAG, which is the thulium holmium YAG laser. So you see that in this table I have briefly given the pumping lasers in the first column, and there are some characteristic wavelengths, the status continuous or pulsed, the bandwidth or the particular wavelengths, and I have also given some particular wavelengths associated with the excimer, nitrogen, and copper vapor, and the particular wavelength associated with the argon ion lasers. And then you see that I have mentioned some important pumped lasers. So these are very important pumped lasers that I have also mentioned, which are being pumped by these pumping lasers. So this completes my answer. So this is the end of slide number 98.